Today I'm talking about the definition of potential difference and potential. First, we discuss about potential difference. Potential difference is the work done by external force against the electric field in moving Q Coulomb from one point P to another point Q against the electric field and along electric field. We try to move plus Q Coulomb from point B to point A existing the electric field. This electric field is generated by the source, right? So the definition of potential difference between point B to point A is work done plus Q Coulomb, moving plus Q Coulomb from point B to point A in presence of electric field. This electric field is generated by the source distribution, point charge, line charge, surface charge, and so on. So the voltage between A and B, it means plus Q plus 1 Coulomb, not Q, this is 1 Coulomb, plus 1 Coulomb from point B to point A. This is the moving plus 1 Coulomb from point B to point A in presence of electric field is against electric field integration, moving plus 1 Coulomb from point B and point A, and E vector dot dl vector. The L vector is different depending on the coordinate system. First case is the infinite line charge. What does that mean, infinite line charge? The electric field is generated by infinite line charge. So voltage difference from A to B and plus 1 Coulomb from point B to point A in presence of electric field. This electric field is generated by the infinite line charge. The work done in moving plus 1 Coulomb from point B to point A in the presence of infinite line charge is the voltage difference from A and B, and this voltage difference A and B is minus 1 Coulomb, moving minus 1 Coulomb against the electric field from point B to point A, E vector dot dl vector. Firstly, we have to find electric field generated by this line charge. We have already known this electric field is low L. Low L is line charge density. This is the line charge density over 2 pi epsilon 0 rho A rho vector. Electric field is represented in cylindrical coordinate. So the L vector is also represented in cylindrical coordinate. This is d low A rho vector plus low d pi A pi vector plus dd AD vector. The voltage difference between A and B is minus integral from B to A. Electric field is low L over 2 pi epsilon 0 low A low vector dot dl vector is d low A low vector plus low d pi A pi vector plus dd AD vector. So A low vector is perpendicular to A pi and AD vector. Only low components survive. So voltage difference between A and B is minus integral from B to A low L over 2 pi epsilon 0 in free space and low d low. This is minus low L over 2 pi epsilon 0 integration from B to A 1 over low d low. It becomes minus low L over 2 pi epsilon 0 and then low from low is B to low is A minus low L over 2 pi epsilon 0 and then A minus ln B. This is minus low L over 2 pi epsilon 0 and then and then A over B. So in order to eliminate minus sign, so it can be log L over 2 pi epsilon 0 ln B over A. This is the voltage difference from B to A in line charge. Line charge is generate electric field, and we try to find the work done in moving +1 coulomb from B to A in presence of this line charge. So case 2 is what is potential difference between A and B in presence of pointer charge. This pointer charge generated electric field. The voltage difference from B to A is the work done in moving in 1 coulomb from point B to point A in presence of electric field, which this electric field is generated by the pointer charge. This is, we try to find work done +1 coulomb from point B to point A in presence of the source charge. This source charge generated the electric field. The work done is against the electric field. So AB is minus integral RB from RB to RA. RB is the distance from origin to point B, and RA is distance from origin to point A. This is E vector dot dl vector. E vector in this pointer charge is, this is Q over 4 pi epsilon 0 r square A r vector. The electric field is represented in spherical coordinate, so the L vector is also represented in spherical coordinate in the r A r vector, plus r d theta A theta vector, plus r sine theta d pi A pi vector. The voltage difference B to A is minus integral RB from RB to RA, and this is Q over 4 pi epsilon 0 r square dr. This is minus Q over 4 pi epsilon 0 integration from RB to RA 1 over r square dr. It becomes minus Q over 4 pi epsilon 0. This is minus 1 over r. R is from RB to RA. It's minus Q over 4 pi epsilon 0 minus RA 1 over RA minus 1 over RB. It can be Q over 4 pi epsilon 0. This is R 1 over RB minus 1 over RA minus 1 over RB. So this is work done in moving +1 coulomb from point B to point A in the presence of pointer charge. This is voltage difference from B to A. And what happens? We have discussed about in moving +1 coulomb point B to point A. If this point B can be reference voltage 0 volt, we can find the potential at point A, not potential difference. We can find potential at one point. This is called potential or absolute potential. Sometimes it is convenient to establish a reference potential at 0. This is 0 volts. We can choose point which can be a reference potential. This reference potential generally can be earth, metal, infinity. This infinity is potential. So if we want to, the potential in point A is potential difference from infinity to point A dl, because infinity is a reference potential 0 volt. So in general, infinity is the reference 0 potential. So potential point A is minus from infinity to A E dot dl. This is potential at one point. So we take an example. This electric field is given, and find potential difference, not potential difference from n to m. So this is potential difference m to n is minus integration from n to m E vector dot dl vector. So E vector is given and is described in rectangular coordinate, and dl vector shall be dl vector is described in rectangular coordinate. This is a dx ax vector plus dy ay vector plus dz az vector. So it can be minus integration, and is minus 3 comma 2, minus 3 comma 2, and m is 2 comma 6 comma minus 1. E vector is 6x squared ax vector plus 6y ay vector plus 4az vector dot dx ax vector plus dy ay vector plus dz az vector. So it can be voltage difference from n to m. This is minus integral from minus 3 comma minus 3 comma 2 to 2 comma 6 comma minus 1. 6x squared dx plus 6y dy plus 4 dz. X and y and z are independent. This integration can be separated. This is minus integration from minus 3 to 2, 6x squared dx plus 6 integration y is from minus 3 to 6 y dy plus 4 integration from 2 to minus 1 dz. So it can be minus 6 and integrations. This is minus 6 multiply 1 over 3 x cubic from minus 3 to 2. This is minus 6 multiply 1 over 2 y squared from y equal minus 3 to 6 minus 4 z from 2 to minus 1. This is 2, it cancels 3, and this is minus 2 cubic minus 3 cubic minus 3 6 square minus 3 square minus 4 minus 1 minus 2. So this is minus 2 multiply 8 minus 27 and 35 plus minus 3 multiply 36 minus 9 and 27 minus 4 multiply minus 3. So it can be minus 70. This is minus 81 plus 12. So 12 is minus 60. This is 9 minus 69, and this is minus 139 voltage. This is the answer of this question. Today we discussed about potential difference between 2 points in the presence of electric field, and absolute potential. It means the potential at one point and another point when another point establish the reference voltage 0 volts. Thanks for listening to this video, and see you next time. Bye bye.